Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So let's step in the last part of the topic on signal operation. Okay, in this slide, I'll show you how to sketch a signal from an equation and how to write down an equation from a given graph. Okay, let's look at an example. Okay, so sketch the following signal given by ft. So the first step, you need to determine the component of the given equation. Okay, so the component meaning that how can you break the signal into how many small signal. Okay, so the first component here is 3u t plus 3. So this is the first one, and ut is the second component, and this one is the third component, and this is the fourth one. Okay, next step 2, you need to identify the component values and range of t. Okay, so now you need to separate each component. So this is the first component. Okay, 3ut minus 3. So the range, this is the amplitude, and this is the t range of t. Okay, so the lowest amplitude is always 0, but the maximum amplitude is the number or the equation appear in front of you. Okay, in front of you. So this is the maximum amplitude in this component. So how about the range of t? So you need to compare this one to general equation of shifting, time shifting. Okay, time shifting t minus t naught. Okay, so in this case, you have ut plus 3, in which this is equivalent to ut minus 3. So in this case, your t naught is minus 3. So this is your t naught. So the range always less than your t naught and larger than t naught. Okay, moving to the second component. Okay, so what's the amplitude? So the amplitude here is 1. So your amplitude range is from 0 to maximum 1. How about the t here? So the t is plus minus 0. So your range of t is from less than 0 to larger than 0. How about the third component? So the third component, maximum amplitude is 3. So it's from 0 to 3. At the amplitude 0, what's the t? So again, when you have shifting, you need to compare with general equation, t minus positive 3. So your t naught here is positive 3. So less than positive 3 and larger than positive 3. How about the last component? So the amplitude is 1. So the maximum amplitude here is 1. So how about the t? T minus positive 6. So your range is less than 6 and larger than 6. Okay, the next step is to calculate the amplitude of signal for each duration of t. Okay, so how to determine the duration? So you look at the first component. So the lowest point is t less than 3. Okay, so this is the lowest point, and then moving upward. Okay, so now t is larger than minus 3, but lower than the next component lowest point. So the next component lowest point is t less than 0. Okay, and then moving up, t now larger than 0. Okay, t larger than 0, but less than the next component lowest point, but less than 3. Okay, and then it's more moving up again. So it's t larger than 3, but less than 6. Okay, now you have reached to the maximum t when t larger than 6. Okay, then you need to consider, okay, these are the component, the first component, the second component, the third one, and the fourth one. Okay, all right, so what's here in the middle? Okay, in between each component, there's operation involved. Okay, so you need to refer to the main equation. So you have minus, it's minus there, and you have positive and positive. So you have positive and positive in between components. Okay, next you need to go through each component and each t. Okay, so let's look at when t is less than -3. So you need to consider every component. Okay, when t is less than -3 at this point, for the first component, what's the amplitude? So the amplitude is 0. How about the second component? When t is less than -3, what's the amplitude at the second component? So any values less than 0, always 0. Okay, moving to the third component, t now is less than -3. So any values less than 3 will be always 0. Same goes to the fourth component. So total them up, so you got 0. So now moving to the next range, t larger than -3. Okay, for the first component, when t is larger than -3, now the amplitude is 3. Okay, look at the second component. When t is larger than -3, okay, but it's still less than 0, so it's still 0. Same goes to here and here. So total them up, you got 3. Okay, moving to the next range, t larger than 0. Okay, look at the first component. Always start with first component. Okay, when t larger than 0, meaning that any values larger than -3, the amplitude is 3. So now t is larger than 0. So it always 3. Okay, next second component, t larger than 0. T larger than 0, the amplitude is 1. Moving to the third component, t larger than 0. Larger than 0 but still less than 3, the amplitude is 0. Still less than 6, so it's still 0. So total them up, t3 minus 1 equal to 2. Okay, moving on, larger than 3. Okay, larger than 3. So the first component, always larger than -3. So okay, finally, since we have calculated all amplitudes within the range of t, so now we can draw the signal. Okay, in t. Okay, so let's draw the axis first. Okay, so this is ft. Okay, let's look at the range when t is less than 3, and then -3 to 0, 0 to 3, and then 3 to 6, and lastly larger than 6. Okay, so let's put in all amplitudes in the graph. Okay, so from t, if t is less than -3, the amplitude is always 0. So always 0. When t -3 to 0, so the amplitude is 3. Okay, next range 0 to 3, the amplitude is 2. Okay, 3 to 6, the amplitude is 5. Somewhere there. Okay, it's 5, and larger than 6 is 6. Okay, so it's 6. So lastly, you just connect them all. So then this is your FT. Okay, so before this you have learned how to sketch a signal from a given equation. So now let's do the other way around. So how to get an equation for the given figure. Okay, so for the first step, you need to identify the crossing point T. Okay, so here you have T equal to -3, and then T equal to 0, and then T equal to 3, and T equal to 6, and larger than 6. Okay, so at T, okay, so please recap, okay, revise back types of signal. We have, when we have something like this, so this is called unit step function. Okay, so when the signal being shifted to the left or to the right, for example to the right, something like this. So at 1, for example, so the equation become ut minus plus 1 equal to ut minus 1. Okay, so from here you can identify the component in the equation. So for example, here you can see at t equal to -3, there's one line. Okay, so the second step, you need to draw the flow of the graph. Okay, start from the left to the right. So this one moving up, here going down, and going up again, and going up again. Just consider the vertical lines. Okay. Oops. Okay, just consider the vertical lines. Okay, so at t equal to -3, there's one line. Okay, you have only one line, one vertical line. What's the amplitude? The amplitude is 3. So the amplitude is 3. So it's in the trend of unit step function. So it's ut minus, so in this case the t naught is -3, -3. So you have here the 3 ut plus 3. How about the flow? So it's going up, so it's positive. Okay, moving on to t equal to 0. So you have one line here, okay, that connected to the graph. Okay, one line here again. So what's the amplitude? So the amplitude 2 to 3 is 1. Okay, the amplitude is 1. ut is at 0, so plus minus 0. So it is ut. How about the flow? The flow, the graph going down, so it's negative. Okay, moving on to the next t. At t equal to 3, t equal to 3, so you have one line here. Okay, so what's the amplitude? So from 2 to 5, so the amplitude is 3. So it's 3 ut minus, in this case it's positive 3. Positive 3. Okay, so the equation is 3 ut minus 3. How about the flow? So the graph going up, so it's positive. So moving to the last point, so t equal to 6. So what's the amplitude? The amplitude is 5 to 6. The amplitude only 1. So 1 ut minus, what's your current position? Positive 6. So positive 6. So it is equal to ut minus 6. How about the flow? So it's going up. It's positive. So now you just need to list them all. So xt equal to, from the top 3 ut plus 3 minus ut plus 3 ut minus 3, and then plus ut minus 6. So let's compare to the main equation. So it's 3 ut plus 3 ut plus 3 ut minus 3 plus ut minus 6. So that's correct. Okay, let's have another example. Okay, so given an equation ft, so you need to draw or sketch how the signal looks like. Okay, so the first step, you need to break the equation into components. So you have the first component here, you have the second one, and then the third one, and the fourth one. Okay, next you need to detail up the values, the amplitude and the range of t for each component. So the first component 3 ut, so maximum amplitude is 3, so the range of t plus minus 0. Okay, the second component, the maximum amplitude here is t, and still here is t plus minus 0, so the range of t is still less than 0 and larger than 0. Next one, the maximum amplitude is t minus 1. So since this is the equation or the values stated in front of you, how about the range of t? So here is t minus positive 1. So t less than positive 1 and larger than positive 1. And last one, the maximum amplitude is 5. Okay, so the range of t minus positive 2. So it is less than positive 2 and plus positive 2. Okay, let's work out on the range. So you have less than 0 and then larger than 0 but less than the next component. Okay, it's still the same range. So moving to the next component, less than 1. Okay, and then larger than 1, 2 but less than 2, larger than 1 but less than 2, and lastly larger than 2. Okay, next calculate the amplitude for each duration and for each component. Okay, look at the first component. When t is less than 0, the amplitude is 0. The second component, when t is less than 0, always 0. Same goes to the third component and the fourth one. Total them up, you got 0. Okay, when t is now larger than 0 but less than 1. Okay, larger than 0 for the first component, the amplitude is 3. The second component, larger than 0, the amplitude is t. Larger than 0 is still 0 and 0, so it is 3 plus t. Okay, the next range, larger than 1. Okay, any values larger than 0, always 3. Any values larger than 0, always t. Okay, the third component, larger than 1. So now larger than 1, it is t minus 1, t minus 1. And then here, larger than 1 but less than 2 is still 0. So the total amplitude here is 3 plus t minus t is 3 plus 1 is 4. Okay, please take note with the notation, okay, whether it's negative or positive for each component or only single component. Okay, next, the last range, you get 3 here, and then get t minus 1, and last one, larger than 2, the amplitude is 5. So you get the total amplitude minus 1. Okay, finally, let's draw the signal. Okay, as usual, get the range of t less than 0, all positive values, so 0 to 1, 1 to 2, and larger than 2. So the first one, t less than 0, the signal always 0. So here is 0, so less than 0. Okay, 0 to 1, 3 plus t. So how to calculate this? Okay, so range from 0 to 1. Okay, so you can put 0. When t equal to 0, it is 3. When t equal to 1, it is 4. So when t equal to 0 is 3. Okay, when t equal to 1 is 4. So it's there. Okay, and 1 to 2 is 4, and minus 1 when 2 onwards. Okay, then connect them all. Oops. Oops, sorry for the drawing. I hope that's okay. Okay, right, so this is, oh, the last one. Okay, so you have the final signal of ft, and don't forget to label the axis. Okay, so for okay, let's write down the equation of the given signal. So this is a bit challenging since you have other than vertical lines. Okay, in the earlier example, you see only vertical lines connecting each of the sequence. Okay, but in this case you have slopes or gradient, or also known as ramp. Okay, ramp function. Okay, please remember the basic equation of unit step function, ut minus t naught, and the ramp function, the one that have slope, t minus t naught ut minus t naught. Okay, so to write down the equation, the first step you need to identify vertical lines, how many vertical lines you have connecting each t, and how many ramp or the line that have gradient or slopes crossing each t. Okay, so let's start with the first point. Okay, so here you have the first line at 0. Okay, I will recommend you to just draw the arrow for vertical lines first, starting from the left to the right. So from left, so this one going up, next vertical line is here, so it's going down. Okay, that's all for vertical line. But for the one that have slope, that have gradient, okay, this one have gradient, so you need to consider the direction from the beginning point and also the last point, the end point. Okay, so to start with, let's consider at t equal to 0. Okay, so at t equal to 0, okay, along this line, okay, so along this line, how many lines connected to t equal to 0? So first, you may notice that you have the vertical lines. Okay, so let's label it. You have 1v, meaning that you have one vertical lines. So what's the equation? Remember from the earlier example. So the amplitude here is 3 u t plus minus 0, t minus t naught. In this case, your t naught is 0. So plus minus 0. So how about the sign? Is it positive or negative? So since the direction is going upward, so it's positive. So what else? At t equal to 0 also, you may notice that there's starting point of the slope. Okay, so the starting point of the slope, so you have one slope. Okay, so the equation for the slope will be t minus t naught. In this case, your t naught is 0, u t plus minus t naught, so it's 0. Okay, how about the direction? Okay, so the direction from this point, okay, from this point is going upward, so it's positive. And what else missing is the gradient. Okay, for vertical lines you have the amplitude, but for slope or ramp, you need to consider the gradient. So gradient equal to y over x. So y here is 1, x is 1. So the gradient equal to 1. So it's 1 t u t. Okay, any other lines connected to t equal to 0? Okay, no, only 2 lines. Okay, moving to the next t. So t equal to 1. So how many lines connected to t equal to 1? Vertical or slopes only, okay? Horizontal lines you don't have to consider. So in this case only 1. So you have only slopes connected to t equal to 1. Okay, so from t equal to 1, the direction is, okay, this is the beginning point, so the direction to the end point is looking downward. Okay, so you only have one slope, okay, and then it's looking downward, so it's negative. How about the gradient? Gradient is y over x, so y over x, and then you have t minus, so here is positive 1, so positive 1 u t minus positive 1. So this one equal to negative t minus 1 u t minus 1. Okay, next look at t equal to 1. So t equal to 1, t equal to 2. Okay, so t equal to 2, how many lines connected to this t? So only one vertical line, so you only have one vertical line. Okay, so it's pointing down, so it's negative. How about the amplitude? 4 and 1, so it's 5. So u t minus positive 2, so it is equal to negative 5 u t minus 2. So you have considered all t's. So now let's write down the complete equation. Okay, so the complete equation, you just sum all components up. Okay, so in this case you have ft, oops, okay, so the final equation ft equal to, so this is the first component, 3u t, and this is the second component, plus t u t, next this one or this one, minus t minus 1 u t minus 1, and last component you have minus 5 u t minus 2. Okay, so let's compare to the actual equation. Okay, so you have 3ut plus tut minus t minus 1 ut minus 1 minus 5 ut minus 2. Okay, so I would like to remind you, for unit step function you have the amplitude here. Okay, you need to consider the amplitude, but for ramp function you need to consider the gradient, in which equal to y over x. Okay, alright, so that's all. Thank you.